Welcome back to Chapter 1, Overview of Virtual Technology, Part 2, pages 5 through 11, where we'll be looking at the topic of how virtualization software works through licensing requirements. Figure 1.2 on page 6 shows how hypervisors use two main files to run the virtual machine. One is a configuration file. Each virtual machine has a configuration file that contains settings for that virtual machine's hardware, like how much RAM it's going to have, number of CPUs, hard drive space, etc. is all stored there as shown in this diagram. In addition to the configuration file, each virtual machine also has a virtual disk file. This file is typically stored on the host computer's hard drive, but looks to the virtual machine as if it's an actual separate drive. And the virtual disk file contains a bootloader, along with the operating system files and possibly user data. The virtual machine's disk files may be stored as just a single file, or in some cases you can store the virtual disk as multiple files, which can be handy if you have very large virtual disk files. In addition to accessing the virtual disk file on the host computer, virtual machines can also have access to network-based storage, such as network-attached storage, NAS, or storage area networks. We'll get a chance to set up and use a NAS and storage area network during our exercises in Chapter 8. Another difference between hypervisors is that VMware hypervisors do all their hardware access from within the hypervisor itself. However, hypervisors that are based on open source Xen and KVM, as well as Hyper-V hypervisors, use a special guest called domain 0 in Xen, or called the parent partition in Hyper-V. And this special guest has access to the host computer hardware, so it actually performs the hardware access for the hypervisor and then returns the results to the virtual machine. Using domain 0 or a parent partition guest to access hardware can cause competition for hardware resources and slow down system performance. Perhaps that's one reason why VMware hypervisors tend to be faster and better performers in heavy load environments. On page 8, take a look at processor requirements for virtualization. First is multi-core. Most virtualization software requires multi-core processors in order to provide for good performance. Next we have hyper-threading. Hyper-threading is a capability of many CPU chips to create additional virtual cores that the hypervisor can use to improve performance of virtual machines. Third is hardware virtualization. This is a capability that's built into most CPU chips today, and it allows the actual hardware of the chip to perform virtualization processes internally instead of through software. AMD calls it AMD-V, and Intel, the virtualization technology, is just known as VT. So look for AMD-V and VT on your processor chips. You may have to enable this capability through the BIOS in order to make it work. Data execution prevention helps to isolate VMs from each other by enabling memory flags that protect areas, making them non-executable. This is very important for security, so that one virtual machine cannot access information on other virtual machines. There's a number of memory requirements and capabilities. First of all, memory is probably one of the most limiting factors when it comes to how many virtual machines and applications you can run on your host. Host systems must have enough memory to run each of the VMs along with their applications. Today, most virtualization software does allow for memory overcommitment. This allows you to load more VMs than the total amount of memory in your host. Most of the time that works pretty well because the VMs aren't using all the memory and it gets released back to the memory pool. But it also can cause memory crashes if all the hosts start maximizing their usage. The shadow page table, mentioned on page 9, is used by the hypervisor to keep track of this memory and what pages have been allocated to each of the guest VMs. SLAT, or second level address translation, is a CPU feature you'll probably want to make sure your computer has, because it makes it possible to avoid overhead that's associated when you have software managed shadow page tables. So SLAT will improve your virtual machine performance. And remember earlier we talked about overcommitting RAM? Well, one thing that can happen is that VMs, guest operating systems that are running in those VMs, sometimes fail to return memory to the page table. Ballooning is a capability which requires each of the guest OSs to have what we refer to as a balloon driver. The hypervisor can then signal that balloon driver to take up extra unused memory, forcing the guest OS to release that memory back to the virtual machine shadow page table. On page 10, we talk about storage requirements. We mentioned earlier that on your each of your hypervisors requires a configuration file and a virtual disk file. So one thing you need to figure out is how much storage space your virtual machines are going to use if you're running multiple VMs on a host computer. And one method, of course, to provide for additional storage is to use network storage. Most data center virtualization products like vSphere and Hyper-V allow you to use NAS or storage area networks to put data, especially data that's going to be shared amongst multiple virtual machines. Page 11 discusses networking and peripheral requirements. VMs can be configured to use the host computer's network interfaces, and there's a few different ways that this can be done on type 2 hypervisors. One is what's called host only, and this means that the virtual machine can only communicate with other virtual machines on the same host. It does not go out to the physical network card. Bridged allows the virtual machine to go out to the physical network using the network interface card and its own IP address. In NAT mode, the hypervisor acts like a network router, and so the hypervisor then will take requests from the virtual machine for accessing the outside network. It essentially puts its IP address on and sends it out, and then when the response comes in, it pushes it back to the virtual machine. So NAT provides a little more security as far as outside access to the virtual machine. We'll be looking at these different network types when we get into chapters 2 and 3 and configuring the network interface. Data center applications, the host computer may require multiple network interfaces. This provides higher networking speeds because it can send packets out on different paths, and also supports clustering and load balancing. In addition, having multiple network cards can provide you with redundancy in the event of a network or card failure. And last but not least, we have licensing requirements on page 11. There are two major components for licensing. One is the hypervisor itself, and the other is the guest operating systems. There are different types of hypervisors that we've mentioned. Open source hypervisors like Oracle VM would not require any licenses. Other products like VMware Workstation Pro requires you to get a license for the hypervisor. Once you have your hypervisor loaded and you create your virtual machines, then certain operating systems such as Windows and Apple and Macintosh will all have to have licenses. Other packages that are more open source like Linux may not require its own license. So when setting up a virtual environment, you have to be considering licensing requirements, which can be a major factor, of course, in your overall plan for implementing multiple virtual machines. Okay, yay, that brings us to the end of part 1. Party time. In part 2, we'll be taking a look at virtualization products that we'll be working on throughout the course.